Hello everyone. In this video, I will discuss the structural isomerism of coordination compound. So before that, I have to first tell you what is coordination compound. So coordination compound means, let's say this is one molecule, complex molecule. Complex means why? Because there are many atoms. Cobalt is there, nitrogen is there, hydrogen is there, chlorine is there, right? So this is a complex molecule. If we ionize this complex molecule, we will get some complex cation and then a simple anion. This part is called, complex cation. Cobalt, ammonia, whole 3 plus. Cl minus is simple anion. Why it is called complex? It is called complex because here we have two things. One is cobalt and another one is ammonia. Now, if we try to check chemical test for this cobalt 3 plus and ammonia, if we want to check, we will not get positive result. Means we will not get the individual test for cobalt and individual test for ammonia. This is not possible to get. Why it is not possible? Because in this complex cation, which is inside this third bracket, this is called complex cation. So there is coordinate bond. So ammonia to cobalt, there is a coordinate bond. So because of this coordinate bond is much stronger bond. Because of this coordinate bond, this molecule, that part inside the third bracket, it is behaving as a single molecule. Therefore, individual test for cobalt 3 plus and ammonia, it is not possible. And therefore, we can't get the individual test for cobalt 3 plus and ammonia. We will get the overall, this cobalt and 6 ammonia overall is the complex we will get. Okay, because of that it is called complex. Now, this coordination compound, this is called coordination compound, has two types of valency. This total is called coordination compound. Okay. So in this coordination compound, it has two types of valency. One valency is called primary valency, another is called secondary valency. Primary valency means ionizable valency. Primary valency means it is ionizable. It is called ionizable. Ionizable means if it is ionized, say these are molecule, the part which is outside of this third bracket, this is Cl3, 3 number of Cl. If we ionize it, we will get complex cation 3 number of Cl minus. So this 3 number of Cl minus, these are the ionizable. So primary valency means the part which is ionizable. So here for this coordination compound, there are 3 number of Cl atoms attached. So primary valency will be here is 3. There is another valency called secondary valency. Secondary valency means without inside of this third bracket. This is the secondary valency is also known as coordination number. Means how many number of coordinate bond is there. So here in this case secondary valency is 6 because there are 6 number of coordinate bond is there. Right? So in coordination compound, remember that there is a two type of valency. One is primary valency which is ionizable. Another one secondary valency which is not ionizable. This coordinate bond cannot be ionized. Ionization only possible if there is some ionic bond. Okay, if there is covalent bond, then also ionization not possible. If there is coordinate bond, there is also ionization not possible. So for coordination compound, the part inside of this third bracket, okay, so number of coordinate bond is the secondary valency. Outside of the third bracket, number of atom is the primary valency. Okay. Now we will discuss the structural isomerism. Structural coordination compound, it has 4 types of structure, not 4, 5 or type of structural isomerism, but here we will discuss only 4 types of structural isomerism. One is ionization isomerism, hydrated isomerism, linkage isomerism, and lastly coordinate isomerism. These 4 types of isomerism we will discuss today. What is isomer? Isomer means same chemical formula, but different will be in their nature, different will be in their structure. So here this is structural isomerism, so difference will be in their structure, but the chemical formula will be same. If we take for ionization isomerism, if we take these two examples, okay, these two examples, So you can say these two compounds, cobalt ammonia whole 5 Br SO4. This is also cobalt ammonia whole 5 Br SO4. In both compounds have the same molecular formula, but their structure is different. Right? What is the difference? Here inside the third packet there is Br, and here inside the third packet there is SO4. Means inside the third packet means this is called coordination sphere. This part is called coordination sphere. Okay, this part is called coordination sphere. So now, in first molecule, both are same chemical formula, same molecular formula. So, but their structure is different. Why different? Difference in their coordination sphere. So, inside in this coordination sphere, there is Br and there is sulfate. Okay. So there is sulfate, there is Br. Now they are called ionization isomers. Why? Because if first molecule is ionized, okay, if first molecule is ionized, so we'll get this is the ionization valency, which outside of the coordination sphere is ionizable, inside of the coordination sphere is not ionizable. So if we ionize it, means if we put it in a solution, it will give you, this is a 2+ complex cation, this sulfate, this is simple anion, sulfate. Okay. If second molecule is ionized, we'll get, this is the complex cation, cobalt ammonia whole 5 sulfate plus Br minus. Okay, anion. Okay. So these are the things. So these two compounds are differentiated only based on their ionization. Right? These two compounds, same molecular formula, but their ionization is different. After ionization, we will get different complex cation and anion. So because of that, they are called ionization isomer. Right? Same molecular formula, but because of ionization, if we same molecular formula, but if we ionize it, we will get different complex cation and anion. So because of that, it is called ionization isomers. Now, how we can detect these two isomers? In first case, if we use BCl2, barium chloride, BaCl2, we will get the precipitate of barium sulfate. We will get precipitate of barium sulfate. Right? It is a white precipitate. Right? And in second case, if we use BaCl2, we will not get any precipitate. Right? So using BaCl2 and the reagent, we can detect these two isomers. So for if we give BaCl2, then for first isomer it will give you barium sulfate white precipitate, but the second isomer will not give any precipitate. And also we can use another reagent, silver nitrate. If we use silver nitrate, second isomer will give the precipitate of silver bromide, yellow precipitate, and the first one will not give any precipitate. Okay. So these two isomers can be differentiated by use of these two reagents. One is barium chloride, BaCl2, and another is silver nitrate. Next, come to the hydrate isomerism. Hydrate isomerism is very simple. So in this case, we have different number of water molecules in the coordination sphere. Okay, the part inside the third packet is called coordination sphere. Now you can see these three molecules A, B, C. They have same molecular formula: chromium, H2O whole 6, Cl3. Second one also chromium, H2O whole 5 inside, one is outside. Total 6 and Cl3 2 plus 1. There are also chromium. You can 4 plus 2 6. Cl2 plus Cl. Okay, 3. Okay. All are same molecular formula, but difference in their number of water molecules placed inside the coordination sphere. So because its hydration, amount of hydration is different, so we can say they are the hydrate isomerism. How we can detect these three isomers? We can detect it by simple silver nitrate test. Okay? If we use silver nitrate, then from first isomer we will get, there are 3 Cl molecule ionizable. So here we will get 3 number of AgCl precipitate. Okay. If we use silver nitrate in second case, we will get, there are 2 Cl, so we will get 2 number of silver chloride precipitate. and there is only one Cl outside of the coordination sphere. So if we use silver nitrate, we will get only one silver chloride precipitate. So amount of precipitate will be different. In first, if we take same amount of these three molecules, same amount, and if we use silver nitrate solution, the amount of precipitate will be different. So first case we will get more silver chloride precipitate, second case we will get less silver chloride precipitate, and third case we will get very low silver chloride precipitate. So based on the amount of silver chloride precipitate, we can detect these three isomers. Another way of detection is their conductance will be different. In these three isomers, their conductance will be different. First case, if it is iodized, we will get 3 number of Cl minus. There will get 2 number of Cl minus. There will get only 1 number of Cl minus. So number of Cl minus will be also different in these three cases. So this is the all about hydrolytic isomerism. This is called hydrolytic isomerism because there is different number of water molecule. Water is called water molecule inside the coordination sphere. Okay. Next we will discuss the linkage isomerism. Linkage isomerism. Now linkage isomerism, first I am taking two example. This is two example: cobalt ammonia hold 5 NO2 out inside the third bucket and outside is 2Cl2. Second one, cobalt ammonia hold 5 ONO inside the third bucket, outside Cl2. First one is yellow in color, second one red in color. Why it is called linkage isomer? Linkage isomer, you can see in both cases same molecular formula, but the linkage between metal and ligand is different. This linkage isomerism is possible if there is an ambidentate ligand. What is ambidentate ligand? Ambidentate ligand means ligand having two donor sites. For example, if we take this one, nitro. Okay. If we take two donor sites, nitro is one ligand. If we take nitro molecule, so there will be two donor sites. One is nitrogen, another one, there is nitrogen, one donor site, another one, O minus, this is another donor site, second donor site. So same ligand, you will have two donor sites. Now, in sometimes this ligand use only nitrogen donor site to form the complex, like nitrogen to metal electron donation. Why it is forming? This is called nitro complex. If it use the second donor site like O minus, then electron donation occurs from oxygen to metal. Then it is called nitrito complex. Right? So linkage is different. One is nitrogen and metal linkage, another is oxygen and metal linkage. When linkage is nitrogen and metal, this is called nitro. When it is oxygen and metal, this is called nitrito. So linkage is different, so it is called linkage isomer. So in these two examples, you can see one is nitro, where linkage will be nitrogen and cobalt, and there is nitrito, where the linkage will be oxygen and cobalt. Since linkage is different, so their crystal field splitting will be different. Therefore, the gap of energy gap will be different. So the color is also different. Similar linkage isomerism also possible with thiocyanate, HCl. In HCl, one donor site is sulfur, S minus. If we write the resonating structure, then we will get another donor site, N minus, second donor site. When the sulfur donor site is used, so when sulfur donor site is used, means sulfur to metal complex formation is occurs. This is called thiocyanate complex. If nitrogen donor site is used, second one, so nitrogen metal complex formation occurs, then it is called isothiocyanate. Okay, so this will be called isothiocyanate. Okay, so these two complexes form these two when sulfur donor site is used, it is called thiocyanate complex. When nitrogen donor site is used, then it will be called isothiocyanate complex. Okay, so these are the two different donor sites used. Therefore, this is called ambidentate ligand, and this when since it is ambidentate ligand, when it is from metal ligand complex, the complex will be called linkage isomerism. Last one is coordinate isomerism. This coordinate isomerism is possible when there will be two metal, two metal. When there will be two metals, it will show the coordinate isomerism. Say complex 1. In complex 1, we have cobalt, ammonia. ammonia whole 6 3 plus complex cation, and anion is chromium CN whole 6 3 minus. It is a complex anion. Here coordinate bond is cobalt to nitrogen coordinate bond, cobalt nitrogen coordinate bond, and here coordinate bond is chromium cyanide coordinate bond. Now if we take another complex, this total is a one complex. Now if we take another complex, complex 2, it is chromium ammonia whole 6 3 plus complex cation, cobalt CN whole 6 3 minus another complex anion. Okay, now here coordinate bond is chromium ammonia, and their coordinate bond is cobalt cyanide. Now if we see both cases, same molecular formula. Molecular formula means total number of cobalt, total number of chromium, total number of ammonia, total number of cyanide will be same for complex 1 and 2, but difference in their coordinate bond. In first complex there is cobalt ammonia coordinate bond and chromium cyanide coordinate bond. In second complex there is chromium ammonia and cobalt cyanide opposite coordinate bond. Since coordinate bond is different, so we call it coordinate isomerism. Okay. So this is all about the fourth type of isomerism: ionization, hydrated, linkage, and coordinate isomerism. Okay, this is finished. Thank you for listening.